Hi all, warm wishes to each and everyone. Today in this lecture, let's discuss the solutions of trigonometric functions. What do you mean by solution of a trigonometric function? So it's like solving the trigonometric equations. So solution of any equation is nothing but you have to find out the values of those x such that the equation satisfies. Let me consider this equation x plus 2 equal to 0. So, what is the solution of this equation? I think you've already seen these kind of questions. X plus 2 equal to 0. So, x is minus 2. Minus 2 is one of the solution of this equation. In the same way, x square equal to 4. Then what are the possible values of x here? So, right, plus 2 and minus 2. So, minus 2 and plus 2 satisfies this equation. So, these are the solution of this equation. In the same way, in trigonometry, you have functions like sin x, cos x, tan x, and the remaining functions. For that, you have to calculate the solution of the particular trigonometric function. For that, let's consider the first sin x. So let me take sin x equal to 0. Correct. Sin x equal to 0. So what all values can come here? So sin of which value is 0? Yeah, just pause and think. Yes, you are right. So it is 0, pi, 2 pi, 3 pi. Before telling this, let me show you the exact sine graph, like where you will find that functional value is equal to 0. See, this is the Desmos, it's a graphing calculator. So I will draw sin x here. Yeah, look at this graph. So wherever the y is becoming 0, that is sin x equal to 0, right? So our first point is this one, y equal to 0. At 0 it is 0, at pi it is 0, at 2 pi it is 0, and it is 3 pi it is 0, and so on. 4 pi, 5 pi, 6 pi. If you go left side of 0, at so minus pi it is 0, and again it's minus 2 pi it is 0, and again it is at minus 3 pi it is 0, and so on. It will continue till minus infinity. So x can take 0, pi, 2 pi, 3 pi, and so on. Correct? In the left hand side, it can take minus pi, minus 2 pi, minus 3 pi, and so on. Correct? Yes. Okay. Now, so in solution, what you will write, you have so many values. For all values you will get 0 only. So for that only they have categorized these solutions in two ways. They are, first one is principal solution, principal solution, and the second one is a general solution, general solution. So principal solution, the range of the principal solution is 0 to 2 pi. So 0 including to 2 pi including 0 close to 2 pi close. So whichever values you will get between 0 to 2 pi. So if I show you the graph, then see, at a 0, at 0 it is 0, at pi it is 0. So there are the two principal solutions for sin x equal to 0, right? Correct. For 2 pi also it is 0. So there are three solutions for sin x equal to 0 for the range 0 to 2 pi, right? Okay, this is about the general principal solution. What about the general solution? General solution is, this will cover all the points, all the points, all the points including principal solutions. I think I made it clear, like what is general solution or what is principal solution. Principal solution covers in between 0 and 2 pi, and general solution, it covers everything, all the points wherever that function satisfies. Okay. Okay, let's the principal solution answer is, for the principal solution for sin x, answer is 0, pi, and 2 pi. Correct. For a general solution, you have to write all the points. How will you write all the points? So it's a tedious job, right? So let's represent them in with using some expression. So this is 0, 1, 2, 3, 0, minus 1, minus 2, minus 3. These are integers, correct? So the solution x can take n pi values. n pi, where n is integers. So if you take n equal to 0, then you will get this value. N equal to 1, you will get this one. N equal to 2, you will get 2 pi. N equal to 3, 3 pi, so on. Negative side, n integers, minus also comes. Minus 1, minus pi, minus 2, minus 2 pi, minus 3, minus 3 pi. Got it? So this is the solution of general solution of sin x equal to 0. So x can take n pi, where n is integer. N can be anything, integer, any integer. Let's see the same thing for cos x equal to 0. Cos x equal to 0. So shall I show you the graph? Okay, let me show you the graph. So let me draw the cos x equal to 0. Cos x equal to 0, right? Oh, what I did. Cos cos x, that's it. Cos x. Okay, see, this is the graph of cos x. So where find out the places where it is becoming 0. Yeah, first point is this one. So this is the first point, and second point is this one, and the third point is this one, and so on, right? If you come left hand side of 0, the first point is this one, second point is this one, third point is this one, right? So see, the answer pi at pi by 2 cos is 0, at 3 pi by 2 cos is 0, at pi pi by 2 it is 0, at minus 3 pi by 2 it is 0, at minus pi pi by 2 it is 0, right? Let's note on those points. So it is at pi by 2 it is 0, at 3 pi by 2 it is 0, at 5 pi by 2 it is 0, and next 7 pi by 2 it is 0, and so on. If you go at left hand side, minus pi by 2 it is 0, minus 3 pi by 2, minus 5 pi by 2, and so on, right? Right, okay. So if you observe this pattern, so it looks like, see, 1 3 5 7 9 11. At the left hand side, minus 1 minus 3 minus 5 minus 7. So it's a odd numbers. How will you represent the odd numbers? With a expression. Think over it, pause and think. How will you represent the odd numbers using the expression? Yes, this will be represented using will take the value 2n plus 1 pi by 2. So 2n plus 1 is the general representation for odd numbers. So if you put n equal to 0, you will get 0 plus 1 into pi by 2, right? If you put n equal to 1, it will get 3 pi by 2. If n equal to 2, you will get 5 pi by 2. If n equal to 2, you will get n equal to 3. If you will get 7 pi by 2. Same way, if you put n equal to minus 1, you will get minus 1, minus 2 plus 1, minus 1 minus 5 by 2. This one you will get. If you put minus 2, you will get this one. So this will represent all the numbers where n belongs to integers. So next point is